Yes, my friends, I'm Professor Kumar and you are at Galaxy Tutorials. We are now studying at Galaxy Online Learning. That is the name of our channel now on YouTube. Please search for Galaxy Online Learning. Kindly subscribe to the channel. Okay, please like or you should dislike the videos. Give us your valuable comments. Okay, communicate it to us. Please bring difficulties. If you feel you require more depth in the chapter or something is not clear, you need something extra or something to be replaced, please let us know. We will solve your problems. After we finish this, I've been asked many times question, how do we go about it? Online learning is just watching videos. Online learning is not just watching videos. You watch videos, you understand the concept, you take down the points, okay, in your notebook, and from the study pack, study the question answers, everything. We will be having recapitulation, revision, and discussion of important questions as we tend to finish the portion and as we come nearer to the exams. In case in between you need something, some particular type of question, no questions, please let us know. So today we are doing for 10 CBSE science, and in science we are studying chapter 14, sources of energy. Those of you who have not registered, 3 study packs have already been issued. Please register. Okay, communicate to us on the phone or the WhatsApp group. You may email, give us a call. Please register fast. 3 study packs have already been issued containing the detailed question answers and practice questions, assignments, past paper questions, and concept maps. Okay, so that's quite a lot of all these subjects. You can see we are doing first maths, science, then we are moving to history, geography, and then we'll move to languages. The chapter is sources of energy. In ninth, we were told that energy can neither be created nor destroyed. We were taught law of conservation of mass. Mass and energy are interconvertible. Mass cannot be destroyed, mass cannot be created, mass in the universe always remains constant. So, the total energy in a physical or chemical process, we will have that it is, okay, conserved. Energy does not disappear anywhere. So, if the reaction produces products which do not require that much energy in the molecules, energy will be given out. You will say it is an exothermic reaction. If the formation of products requires more energy in the molecules, we will have to supply the energy and we heat the chemical reaction. It is endothermic. So let's, I'll just put the 2 things. So after this, energy change may be exothermic. This heat is given out during the reaction or conversion, and endothermic. Heat is supplied during the reaction. So 2 things from 9th standard we will gather up. Then also, once we use energy, we use to convert to work, etc., we can't get back always that same energy. Okay, and we can't reuse. These are all, everything is not a rechargeable battery, and even rechargeable batteries, my friends, as you know, are not 100% efficient, and they become weaker and weaker with time, and finally we have to throw them and buy new ones. So, first point we come to, what is a good source of energy? First, subunit. First question we are asking, what is? Now you will tell me, if I ask you, what you will ask me, for what do I need? Suppose I tell you that I want to use energy for my mobile. Of course, I can't place it on my gas in the kitchen and it will get energy. So different forms of energy are required by different processes. But we are talking of something which can be used for combustion, because that's we can measure with a thermometer. We can't measure with a thermometer how much current my mobile is using, and everybody doesn't have a ammeter, voltmeter at home, cut open the mobile and measure or something like that. So that is why we are taking, for simple reasons, that we are having combustible energy sources, or what we can burn, because that is our major thing. To generate electric power also we can use to burn sources and obtain energy. Now first, a good source of energy, or as we say fuel in simple language instead of using such big names, has certain characteristics. First, okay, it is easily accessible. I can get it where I need. If I'm living in Antarctica and I expect I'll find coal there, difficult proposition, my friend. So I better carry the cylinders of gas with me as home, butane, etc. to burn, or oil canisters. So it should be easily accessible. Number one, it should be easy to store and easy to transport. Now we can't have a nuclear plant in our home, because we know we will not be able to store it. We will need lead shielding, we will need concrete shielding, 10, 15 feet concrete structures, which we will not be able to. So what you and I do, my friends, either we use electricity, directly comes in the socket, or we use today piped gas, comes directly by pipe, or we go for a gas cylinder. Easy to store, easy to transport. It is being delivered to you through a pipe, through the wire, or as you can say, through the cylinder. Easy to transport. So we can go to rural areas, villages, mountain tops. So it should be available. Otherwise, some people will never be able to use fuel. Okay. And lastly, it should do a large amount of work per unit volume or mass. So if I burn 1 kilogram of gas, I know that it will do a lot of work. To give you a simple example, now you are getting 16.5 kilo gas compressed LPG in a cylinder at home. You may not be knowing, you may be knowing also, or you can ask your parents. Your mother will tell you it will last for 1 month, it will last for 2 months, it will depend upon the size of the family. So it is doing work. 16.5 kilo is not lasting me 2 days, 3 days, 16 days. It is lasting me 45 days, 60 days. So it is doing a large amount of work for the mass I am getting. So this is what is required. We may have to, give for 1 mark what are the characteristics of a good fuel. And then, my friends, we come to fossil fuels. We first go for when man started using energy source fire. He started, as you know, with those dried grass, dead wood, etc. So our history begins with fossil fuels. After that, we started using coal, after wooden billets, and then after coal, as you can see, we are burning coal, making steam. We're making now electricity, thermal power plants. Okay, so this is what we'll see: fossil fuels, and of course, we are going back to them. As you can see now, all the vehicles, cars, buses, etc., now run on CNG. Okay, we are going to fossil fuel found in the earth by decomposition and found over million of years ago. So 14.1 figure is given. Figure 14.1 on page number 244 of the textbook is given. It shows the relative percentages of the different fuels. Now from that we can find some common fuels, some common sources of energy. First we can find some common sources of energy being used today, which are coal, I have petroleum and natural gas, I have hydro, electricity, hydropower, I have nuclear power plants, and I have wind. There are many, my friends. There is tide, etc. We are not going to all details, okay, but the book shows only this much. So we can write name 1, 2 common sources of energy. Also from the graph we will see that coal is first. Coal, okay, or we'll put in the order. Sorry, I will write number wise. First is coal, percentage, because you must learn to read the graph. Coal. Second, the book goes for hydro. Now, if we see in the book, the diagram in the book, that is not even 1/3. Okay, of course the graph is twisted. And the least when we will see is wind. The last is wind. Okay, so which is the most common source, which is the least? Maximum we need to know from the graph to interpret the graph. Questions based on the diagram. We don't need in between, so we will not bother. Now, next, fossil fuels have a problem, my friends. They cause pollution. Whenever you burn a source of carbon, fossil fuels are carbon based, you will have carbon dioxide and water. Of course, there will be smoke depending on what you are using. Some gases are mixed in a gas, then those poisonous gases will also come out. When you remove LPG and CNG from the bottom of the oceans and oil wells, they are mixed with sulfur dioxide, nitrogen dioxide to small extent. So they have to be filtered. We try our best, but they will still contain. We have to add certain pollutants to that so that the gas smells. So you know the gas is leaking, because gas by itself has no smell. So you'll never know it is leaking. So we have to make it odor by putting a compound, and so you know it is leaking. Then, so pollution is the biggest problem. So, second, pollution is our headache with fossil fuels. Then, the book gives an activity. It says, take a pressure cooker. This is my pressure cooker. Okay. And take a pipe out of it, of the nozzle. And he says, take a ball and stick a play fan in it. So I have put up like aluminium foil or your computer fan. Now, when I heat this, I put it on, so I have a source of heat and I have a flame. So when I heat it and I have water inside, this is pressure cooker. Okay, this is hose pipe. This is a light fan. Light in the sense, don't take your ceiling fan, micro fan. So when I heat, steam will come out. The steam will push the fan and the fan will work. Now, the fan behind fan can be having a coil, and two magnets north and south can be kept, which we will teach you in magnetism. Okay, so when the fan rotates, the coil rotates between the north and south pole. It produces electricity. So the electricity it produces can be collected, and it can go also to a dynamo. Dynamo is that small thing near the wheel of the bicycle. Okay, so you can directly put the dynamo if you don't need a current generator. And how you cycle, the headlight of the cycle comes. More harder you cycle, more the light. Lighter you cycle, less the light. So we can do this experiment by this method. When we do it by this method, this is what we do in the real way. This is just to show you a principle, dynamo. Dynamo, of course, will give you a lamp, so your lamp will burn. Okay, and light will be there. Okay. Or, and as we said, here, and I will do this, here you can charge it and keep it in a battery also. That is what we do in the car. So your battery gets charged in the car. The dynamo is going on making and the car lights shine. And extra current also made along with it is stored in the battery. So this is the experiment which shows how we can convert heat energy to steam. Steam giving mechanical energy, pushing the fan, can be converted to electrical energy by magnetism or by mechanical movement, and light is produced. This is the given. So this you should be able. And in short, we call this turbine. We don't say bicycle light for making electricity for country, cities, states. We use a big thing called turbine. Okay, same turbine we will be reading in source of energy, can be also used for hydroelectric plants. Okay, so we will go now. This was the introduction. So we will go into the chapter. First, thermal power plant. What do we need to know about it? That was the experiment we just saw before this. Heat energy. How do we get heat energy? Burning of fossil fuel. Coal, etc. You get heat energy. Okay, and this heat energy, as I showed you, can run a turbine, as we saw in the dynamo experiment, and be converted to electricity through a turbine. Turbine is a big fan which rotates. Then, now this has to be near coal supply. Or today we don't write in the book, but even gas can be used. Gas is given to consumers, so normally we know, but other countries they are burning gas. So we can't carry coal everywhere in the world where we require, so the coal should be nearby. It's expensive to transport coal. Okay, so this is the way of converting heat energy to electric. Of course, as I remind you, pollution will be there in any combustion of organic substance. Second, hydroelectric. So they remove the word electric, which is there, power plant. Now this looks like water power plant. It's hydroelectric, but they make it short form. Here, we take a dam. So there's a dam. This is a dam. And there is water behind it. There is water behind it. We open the gates of the dam. And water comes down in channels. And here are those fans of mine. Okay, when the water rushes, it will rotate the fan, just like how I showed you the experiment, and fan will rotate, mechanical energy there will be. So here, stored potential energy. We don't say water energy. When water is stored, it has potential energy. Here, water rushes out. So first, kinetic energy. From here, it will rotate and turbine to electricity. So one thing you must remember, the dam must be solid. Otherwise, because more water you store, more will be the electric produced. But more water you store has more pressure. The dam may get wiped out. When you are free and you are sitting on internet, please have a look. The Three Gorges Dam built in China is already bending and ready to break. because the design was extremely straight and cheap materials have been used. And it's a big dam. Water applies tremendous pressure. Do not underrate potential energy. Okay? So this is second, but only thing compulsory is that we should have a source of water. So we can't have this in deserts like Rajasthan or Dubai or wherever there is no water. So we should have fast flowing rivers or big waterfalls, so we can make smaller or bigger ones. Okay? Now, these are filled with rain, as you know. We don't fill them. So they are natural sources. We can't fill dams with water, we'll have no water left. Okay, they are sources of water also. Now there are problems. First, it is expensive. It is not easy to build a dam. Okay, very expensive. That money can be used for the people, etc. Second, behind is called the reservoir, where you store the water. Okay, the reservoir behind the dam, okay, will submerge anything growing, all animals, everything will go underwater. The villages, the land will cause submergence, or everything will go underwater. So 20 villages or forest or natural vegetation, animals, all will get affected. Okay, so this is the problem. And thirdly, when you block all this thing, water looks very nice, but when it is near the ends and all, you have a lot of decomposition occurring. Whatever, when the level rises, and the level comes down, so those things which are there at the edges will start decomposing. You will have a lot of methane gas coming out. Okay, and people do not like it. There is public opposition. Why my land, why my village should go to serve electricity to other people in the country who do not stay here? What benefit will I get? Why should I sacrifice? This is a big problem and political problem. So when we were making the Tehri Dam on River Ganga and Sardar Sarovar project on Narmada, we had a lot of protest. Very difficult. Took years and years to cool them down. People get displaced. They lose their livelihood. Their homes go away. Okay? They are given a small concrete. Now you're living in a nice big palatial hut and suddenly you're given a single concrete room in a chawl or something. People get affected. Okay? The job goes, their family breaks, everything happens. And emotionally, they're not happy. So these are two sources given from traditional in our book. Then our book goes now into improved technology. Improved technology for you applying to these conventional sources. Conventional, old, based. How can we use technology? Remember, my friends, from the lower class onwards, we are teaching you biogas, gobar gas, which now we like to call biogas. Don't burn leaf, wood, etc. in your chula. It will create smoke, it gives less energy, then you have to put water to douse it, and then you throw out the remaining. What a criminal waste and pollutant. You are breathing carbon monoxide. Okay? So we suggest that you should do biogas as has been explained to you in lower class. There's a diagram 14.4 on page 247. Learn the diagram of biogas plant. What does this show? The structure is very simple. You have a U-shaped structure and you have a, what you can say, a plate like or a trough like substance, and okay, simple, and a pipe to remove the gas. Very simple diagram. This is called the digester. where digestion is occurring. This is the outlet and this is the inlet. So you take all your waste material, all the kachra of your feed, leaves, dead plants, roots, after processing husk, shells, etc., gobar, that is the excreta of the animals, and urine, and we dump it inside. Okay? And when we dump it inside, you will see it will reach like this. This ferments and gas comes out, methane, which comes out here, which is called biogas. And from here, we remove sludge, the decomposed product, which is a good fertilizer. So this is how we use totally everything from a biogas plant and nothing goes waste. So why don't we do it? Why our society does not have it? Number one, you need every time waste. This is labor based. You cannot have an automatic plant which will put all these things in it. So labor is required. Labor is expensive in cities. Then decomposition occurs. If they have fields where they will remove this black sludge and put, where will you put? You will have to pack the sludge, dry the sludge, okay? And temperature based, when it is cold or it rains, as you see now, things get diluted a bit, biogas becomes less. So your gas will be more supply, less supply, not uniform supply. So for cities and high requirements, we do not prescribe like this. For village, for their requirements, they have bigger areas, free areas, no odor, smell will go, and they can store the litter, used vegetables and plants, they can store the sludge. For them it is easy. So this cannot be universally used everywhere. This is a bit of problem. And it contains, the book says, up to 75% methane. More the methane, better the gas. Pressure is very low, of course. So it's almost an open floating vessel. Okay. And we can do it large scale in rural areas and compress the gas in supply, but we have never thought of it. Do not know why. Okay, but we can utilize things like this instead of wasting. Even the municipality here can make it at those dumps where they're putting the waste and generate electricity and energy sources from the waste. So good source. Then second, we are going for wind energy. My friends, when you go to the Lonavala, Khandala, and you pass the Western Ghats, you see lot of now tall white fans on top of the mountains. Okay, so windmills as we call them. So you will see a big pole is there, and it has got those 3 wings. Okay. Now, as we saw the turbine, when wind comes, this rotates. When this rotates, okay, as I told you, the coil rotates between a magnet and electricity by dynamo is produced. Also, you can grind corn because there is mechanical energy, it is rotating. So you can grind corn, make wheat flour, etc. can be used for processing. It can lift water. It can serve as a water pump for villages also. Okay. Now, trouble is first area. You can't have one windmill and it will supply. You will have to have a chain of windmills. Second, it is an eyesore. People don't like it. Seeing windmill every day. Rural, no problem. City people don't like it. If I put 10 windmills around your house, you will not like it. Okay. And third, they are also expensive because of wind. The parts, moving parts are there. So you will have to. Earlier they used to be made of wood and local material, but now you have to import, and all this is. So we can do it in the rural area, in farms and all, and supply electricity, some electricity to cities also. Okay. Denmark is the king in this technology. 25% of their energy comes from windmill. It is non-polluting. Okay. And largest wind farm is near Kanyakumari in Tamil Nadu. Okay. So that should be kept in mind. So this is environmental friendly. Environmental friendly. Why? Natural raw material. wind. You don't have to store, do anything, and no pollution. You're not burning anything, no waste is generated, etc. Okay? But my friends, remember, when there is no wind, okay, at periods when the wind is very slow, no wind, electricity will stop in a house. Of course, you'll say, so there should be high wind. High wind means more damage to the windmill. So these have to be taken into account. So everything is not as simple as it looks. It's not we will hold one fan in our hand, okay, for city and all. We've got taller structures, the blades are heavy, okay. So this is where, but technology is making them easier and easier. So this was the next subunit in our textbook. We will go further. Okay, alternative, non-conventional, which we have never used, or also we call alternative, because every time you keep screaming that conventional sources cause pollution, question asked to you, so what do we do? So these are depending on technology, and these are latest because earlier we did not have the technology to use them. First in this is solar energy. Earlier it was fun, gimmick. Today it is perfectly viable. And just this week I've seen research being carried out by University of Cambridge, and they're printing out on plastic solar panels. And so it's cheap, okay, it's flexible, very thin, and just can be applied on the roof-like structure. So we are moving ahead, and they made a very cheap solar ink. You just, they say, require 3 printers, and that's enough for the making electricity for the town. So now 3 printers, what should be the cost? How much will the plastic cost? How much will the ink cost? You see how cheaper it becomes. Okay, but initially research and all, scientists, money is required. Later, this will be a better source. Earlier, we were using glass. Till everywhere you will see blue glass structures, which will trap energy, solar energy. There were troubles. First, dust. More they get covered with dust because they are on the roof and on the top. Second, glass is liable to break. Somebody breaks purposefully or it breaks. Delicate, difficult to handle, and very expensive. Glass work is very expensive. Okay? And don't imagine whole sun, morning sun, afternoon sun, somewhere there is less sunlight, somewhere there is more sunlight, and we don't utilize the entire sunlight. Maximum we can use is on a solar panel, if we are very lucky, is 50%. Normally it will be 10 to 15%. So you see how big area you will require to make it 100%. Okay? Usage. Then we also have a solar cooker. This I will put as solar panels. Solar cooker is a good concept. Okay, of course started rurally. Here we take a box. So I have a box. Box is painted black inside, and I have a vessel inside. And the box has got a lid with hinges fitted. Okay, so this is how it looks like, and there is a mirror on top of it. It is black inside, so that energy is absorbed, and you have a vessel inside. So the sunlight falls on the mirror, gets reflected, and you close the box, of course. Okay, and when you need to cook, and otherwise you just reflect into it, and this reflects a lot of light. We can of course use concave and lenses and all, which will make it better. And we don't need to have those big glass, thick glass, just a foil turn or a gentle curve will also solve the problem. And this, as you can see, is non-polluting, cheap, and no problems. They don't have any moving part. Silicon sand required to make glass and solar panels is easily available and all. And we are using signals and all now have solar panels on top to charge small things are now. We are also thinking of, you have read in the papers, still experimental, entire train will have solar panel on top, ones like which run on the areas where there is full sun. So this will save a lot of electricity, you see. So we are going for it, okay. But as I told you, it's not cheap. Everybody at home cannot get this fitted and maintain. You rather say I will pay the bill monthly than spend at a time so much rupees. Then energy from the sea. Such a vast sea, 75% approx land is covered. So here I can have tidal energy, where there are tides, and I can have wave energy at the shore. France has worked on this plenty. In tidal energy, as you know, the moon, geography has taught you, the moon pulls the earth and the earth is spinning and the level of water rises and falls, because of which we have tides, okay. We make a small dam and the water rises and falls, okay, not quite into the sea but near the land, but little inside. The movement of water up and down, so if I in the sea I keep a dam, the movement of water up and down, the water level keeps moving like tides, okay, bubble up, bubble down. So this causes conversion into electricity. But my friends, who would like, now we go to Chowpatty and we put up these dams, who would like it? And how many dams you want to put? How big dams you want to make inside? So this is theoretical concept, very nice. Practical concept, difficult. So they went for wave energy. In wave energy, simple, we take a piece of, like say, a thermocol, okay, and tie a small weight to it, and this is on water. So when the wave comes, it pushes it. You remember wave moves up and down. Wave does not carry substances towards like that. So in the sea, this will move up and down, and that will generate electricity. Again, untidy. Entire beach will go. The beach front will look horrible. So this can only be done in remote areas. France is working lots on it. And then ocean thermal energy. Such a big source of water, and it gets heated during the day, okay, and surface water has higher temperature than bottom water, so we can use this difference in temperature also to generate electricity. Geothermal. Geo for geography, earth, thermal for heat. Wherever there are hot springs, hot water coming out, and volcanoes, we can use that heat energy. We can take pipes from the hot springs and then give back the water into the water source after we use it, like turbine, because natural steam is formed. In these cases, those which are near the volcanoes and all, we have it in New Zealand and USA. But again, not very practical, not everywhere, and you require the patience and the money to build them. Okay, but very nice because unpolluting, etc. And you should be having that much knowledge of science. Nuclear energy. This, my friends, is always in the news. We take uranium, we do fission by bombarding it with electron, it breaks, heat is released. This heat is used to boil water. The water will drive the turbine will drive the dynamo, and electricity will be produced. But my friends, two problems. First, the cost. Second, the technology. Everybody does not know how to use nuclear energy. Third, danger, radiation. And fourth, accident means death of the town cities. It has happened in 3 Mile Island in USA. It has happened at Chernobyl in Russia. It has happened in Japan. Dangerous. Okay? But, and the leftover, after the uranium is broken, all the products are still radioactive. for another 2000, 3000 years. So they have to be packed in lead, put concrete. Where do we keep it, in whose house? So we find America, for example, is putting it in the pits of the mountains and covering it with sand. Some are dropping it in lead barrels in the ocean. Dangerous, my friends. Today's use, maybe tomorrow's disuse. And when this corrodes or breaks and all, we cannot control radioactivity and we cannot overcome radioactivity. Too difficult. Okay, so this is the trouble with these energy. So basically, environmental consequences we should know. What is important is, it may look very nice, like nuclear energy. But what will happen after a few years? Remember, sustainable development is using the resources judicially today so that tomorrow's people also have it. Here what we are doing, we are using everything and leaving all the pollution and useless stuff for the coming generation. So environmental consequences are much. That is why we like solar energy. At least you don't have to go to the sea, water, nuclear, sun will keep coming. So wherever there's good sunshine, good sunlight, and most of the places have that, we should go for that. That is the easier. And compromise, where we cannot manage the cost. For example, in your city, we are using CNG for vehicles. It's coming to your home, Mahanagar gas. So we are trying to use other sources so that nobody burns coal, etc. Okay, and the load of electricity generation is less. The trouble is, how long will the energy last? Okay, it should be renewable for sustainable development. When you burn plants, coal and convert to carbon dioxide, you say, "Arey, but carbon dioxide will be used for photosynthesis." Sorry. It will cause global warming, Arctic and Antarctic is melting, all the biosystems are changing. Okay, big problems. Today's news you can see in the paper and on the internet that pink snow has fallen in the Antarctic region. Algae is growing because of warming. You see, no life where it's supposed to be, but because of warming now temperatures are better. So as life began on Earth, now plants will start taking over. So everything will change. So it should be renewable, like solar. It can't exhaust, we can't eat up the sun, etc. And we can always use it. Okay, and practically negligible, like hydroelectric, and these things are practically, usage is negligible. It will not get over any day any soon. So we should go for such sources of energy. I've given you all the points, my friends. Go through the question and answers in the book. Okay, please subscribe, please register, please collect your study packs, because study will become late and late for you. Okay, watching video is fun, very nice, I understand everything, but my friends, you don't have an oral exam, you will have to write for an exam. What comes, how it comes, how was it corrected, you will have to collect the study packs. So please do so, and kindly come with all your difficulties. Kindly subscribe to now Galaxy online learning videos so that you are notified. Like today I put up, for example, 4 videos, so you will get all the news of the 4 videos which come. You can make a schedule when to study which chapter, keep the textbook ready, keep the notebook ready with a pen, take down the important points, mark what you don't understand, communicate. Please interact. Okay, my friends, thank you.